All right. I have to do LeetCode. I need to freaking study, man. I've been this entire week and next week I have a bunch of exams. Actually, this next week I just have one more exam, and then I can continue the project. Also, I'm kind of good with this project. This project is getting harder than I realized. But my goal with the project though is this is where here before I start LeetCode. Here's the kind of breakdown. Note down is going to have. I'm gonna use Quill because I realize I have to, let's say I build the editor from scratch. I have to do that stupid ass cursor management. I'm not doing that again, bro. I want to work on the back end. I have some goals with the back end, which is maybe an auth, maybe, I don't know. Because I need to, I'm losing my Go abilities. So, I gotta write that. Figure out like the connection stuff here. It's more like here. So I can do that, and then a database to store stuff. I was thinking of two things, like Postgres to like the I guess like metadata, and then actually the content itself, like we do like blob storage, like or S3 buckets. But the thing is that might be a little expensive because AWS, and it looks like a lot of configuring, and I have no idea how to do that on. I have no idea how to do that here, so yeah, we definitely need to refactor a lot of things. The server won't handle any of the all this stuff because it's not the goal of it. So regardless, let's just do some LeetCode. Kill this one. Let's kill this and then make a new split. Let's open this up and let's do this one. 50%. I think it's today's LeetCode thing. Whatever. Let's try it. Count the number of fair pairs. Given its index nums list, lower upper, okay. We want an integer. Integers nums of size n and 2 integers lower and upper. Return the number of fair pairs. A fair pair is if I j okay. So I guess just in the list, obviously, and the sum of it is in here. Oh, okay. And we just care how many of them. So okay. Count fair pair. The brute force I can do like every single pair optimization. Is the array sorted? Because I do need this incremented. Like I need this ij's. Yeah. If it's clearly not sorted, so maybe we can sort it first. Be greedy. It's not really being greedy. It's more like it helps us find valid pairs. Oh shit. Oh my god. Why did I click on it? Well, yeah, that's a good hint. Sort the array in ascending order. Okay, that's something I can use. There is a single fair pair. Zero, one, 0, 1, 2. 3, so it is in. Okay, that's cool. Let me do the theory real quick. Okay, so if we have an array, let's say like this one. Oh, we need like all this. Let's do this one. This is easy. The answer is 1 for this, so. So let's say we sort it, right? What value do I get? 1, 2, 5. 12579. What does this give me? I have like this pair, I have this pair, I have this pair, I have this pair. Ah, I see now. This low-key might be binary search, because we want to stay in this like kind of range. If it's too big, right? If it's too big, then oh yeah. If it's too big, then reduce. If it's too small, increase, right? Let's start with this pair. So 1 plus that's 10. So it's not, that fails. It was too small, so let's increase it. Let's increase it. It is 2 plus 9. That's 11. That counts, so that's 1, right? Then since it was perfect, where do we go? I don't know. That's the tricky part. Should we move up or down? I guess up. If it's basically too small or we match, then we just move up. Here's the thing, dude. I do kind of miss out on a few numbers. Let's do this. 5 plus 9. That doesn't fit. It's too big. So bring this down. And then let's do this. 12. Obviously too big. So yeah, and then stop. So that was 1. Let's do a more complicated one. Let's do this one. This is not that bad. I don't think this should be too bad. Like a binary search. It's not actually a binary search, but it's more like 2 pointers kind of. If I sort the array, so it's gonna be an n log n and constant space because I'm not really doing any extra space. So we have an L and R here. Try this out. That's 5, so that's 1. Since it, okay, now that's where I need to figure out, what do I do when we find the one that's in the range, right? So 5 was like a bit upper bounded. So maybe we want to, since it was too really close, like if I stay with this, maybe I should decrease R, because like, what am I closer to? The sum, right? 0 plus 5, was I closer to the lower bound or the upper bound? If I was closer to the upper bound, I should probably decrease. So I can do like this, right? This is 0 plus 4, that's another one, so let's do, oops. Let's do 2. This is 2. I'm closer to the lower bound this time, so I'm gonna increase. I'm gonna increase my L. Let's do. So increase L. So let's do L here. Put this here. Should be at 2, but these counted. Where was I at? This counted, so I'm at 2. So I'm gonna move up though, because I was closer to 3, because 0 plus 4 is closer to 3 than 6. So let's put L here. That's good. Now try this out. That's 5, closer to 6. So let's move down. This down. What am I saying? This is R. 3. I think there's a lot more. There's 6. I don't think I'm getting all of them. This is this is 5, so that's 4. 4. Oh my god. 4. 4 is closer to this one, so let's move up L. Why am I rewriting? I'm just gonna move it. Yeah. This is 7 plus 4 is 11, so that's the count. Okay, so we are missing a few numbers, I think. Because okay, what would be bad if I did like this? Try all this way and then try all this way. Try all this way. Like try like doing all the okay, so all the values like this. Here's the thing, that's a duplicate. Who cares if I do, you know? Like if I do this, oops. If I do 0 plus 5, 5 plus, yep, 5 plus 1, 7 plus 5, 4 plus 5. But I don't need a check, right? If it's in the range, should I move at all? Of course I have to move. I could do this one as well. Like this is the same, you know, 0 plus 4, 4 plus 0. Yeah. Let me see something. 0, 4, 5, 1, 3, 1, 4. I see that this only moved once and it stayed here. Why? Maybe it's because just stick with one way if we're, yeah, so I'm gonna stick with all values that are too big and in the range and reduce the R. So, okay, 0 plus 5. It's actually, they start as 0, 3. We notice a pattern. Oh my god, this is index. Okay, so I'm not gonna really know. Regardless though. These are good, so 5 and 4. Okay. This is index 0, 1, 2, 3. Oh wait, hold on. This is not even sorted. What am I doing? Wonder it didn't work. Let me sort this real quick. Sorted. 1, 0, 0, 1, 4, 4. That's, I think, let me try the algorithm again. Maybe it would work if it's sorted. It does, typed. So let's see. This is 7. This is 1 plus 5. That's 6, 4, 8. So this is 7. It's not gonna go. It's too big. Reduce R. Reduce R. Still at 0. This is in, but it's still closer to the upper bound, so I'm gonna decrease that. So that's 2. Then we are at, so that's in, that's close to 3, so we're actually going to increase this. That's 3. So then try this out. It's 5, it's closer to 6, so that down. Where's that 4? This is 5, closer there, so that down. So the count up the pairs were these. No. 1, 2, 3, 4. See, I missed the, that's why I'm missing a few. Okay, so it doesn't work actually. So I don't know when to move these pointers actually. When do I move the pointer? L and R. At 7. This is 5, 4. Would it be bad to just try all of them? I feel like I would have missed a few things. Like I'm missing this one as well. This company. But these companies. Yeah. Do I need to try every single one? Okay, I do know that it has to be in the range. So yeah, it has to be increasing. So like I can't, this is valid, these are all valid. So I can't have it like right here or like this. So I have IJ essentially like this. Lower upper. Let me try one more time. I feel like I maybe miscalculated. This doesn't count, so we're still at 0. Right? Then we'd go, okay, 0. It was, it's not 0, it's 0, but the result was 7. So this would be too big. Let's go move this down. That's good. So this is valid. So this is now 1. Then, so it was like too upper bounded. So should I move down? I'm gonna move down because it was really big. Because it was on the upper side. Now let's try this. That was that. Okay, it was too big, so we move this. We're at 2. Try these 2. That's 5. That valid. It's too big, so we move the right. Then do this again. It's again too big, so we move the right. So it's we lose half. Like we miss all the data. What's the other hint? Okay. As you move the large numbers, both boundaries move up. This is actually harder than I thought. A brute force would just check every pair. But I feel like we could optimize it because of the shortness and the bounds. We know that as higher this goes, the more, the higher we go, the more it fights the upper bound. The higher this goes, the lower this goes, it fits the, okay, and then this one upper goes up, up, up till the upper bound, 4 and 7. I'm so cooked. What am I missing here? 014457. This is confusing. What am I missing? What is this? You move to large numbers, both boundaries down. What does this do? 2 pointers behind pair. What? I don't know what I can do now. There are 6 pairs. How do we get all 6? Is there a pattern with this? 0, 0, 1, 2, 3. Okay. Is there a pattern with this? 0, 0, 1, 2, 3. These pair goes. This is a valid one. This is a valid. That's a valid pair. This is a valid pair. This is a valid pair. 0, 5. This. Wait. 0, 1, 2, 3, 4, 5. No, wait. How does that make sense? Or is this the actual numbers themselves? 0, 1, 2, 3, 4. Okay, actually, because it's not sorted. Wait. Let's assume they're sorted. 0, 3, 0, 4. Where's the 3? 0, 1, 2, 3. And that's 3 and 4 and 5. So this, I missed this one too. Okay, okay. And then we have this one here. 1. We do 1, 1, 3, 1, 4, 1, 3. Four. Okay, I see. All of this. This is valid. That's 5. That's 5. This is 6. Do we notice a pattern here? Oh. What is the pattern here? 0, 1, 2, 1, 4, 5 right here. I notice that they always stay here. Because I guess if your thing exceeds the thing, there's no point of considering you. That's fine. So this is the upper limit. So find the upper limit, find the smallest number, and all the numbers in between it are valid, and their combination. Okay, makes more sense. Right? For example, let's start small to big or big to small. You can start small, like this. Boom, boom, valid. Wait, what about this? 0 plus 1. That's a valid one too. Wait, why is 0? Why is this not valid? Oh, it's too small. Oh. Yeah. Damn, okay. Damn, okay, I gotta make sure this too small. This is good. This is good. This is good. I'm not sure what this hint means. As you move to larger numbers, both boundaries move down. That is kind of true. For each number in the array, keep track of the smallest and largest numbers in the array that can form a pair with this. Oh, I see. Okay, for this number, what is the biggest number I can go? Biggest numbers I can take. This, no. This, yes. 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 Okay. Let's take this. What's the biggest numbers for this? This one? Yes, 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 yes. I guess we can go through each thing. For each number, yeah. Zero, one, like, okay, what's the biggest number I can add with this? I feel like 2 pointers still works here. Minimum. Like, I feel like I had the right idea. I think it's like more like this, this. I just found like every single sub pair. Wait, what would happen if I did this? I feel like it's gonna definitely time out. I plus 1 to length becomes if I plus this. Oh yeah, of course, this dot sort. J lower. This is gonna T league, I'm pretty sure. At least I have a brute force. But all I think is brute force, man. Whatever. Because I can't really solve it. I feel like there's a harder trick to this. Pretty sure there's a harder trick to it. How big is this? 10 to, oh fuck, that's gonna, yeah, definitely be the 10 to the, yeah, look at that, it's taking already forever. What is the optimal way to do this? Yeah, that's pretty crappy. Binary search. Oh, binary search. Two-pointer? Yeah, I had this idea. Oh, you take the difference between the upper plus one. Wait, what? Look for 7. So 7. Okay, so no, yeah, so look for 7. And basically, right. If you're less than the value, then prime minus. Let's see. Try to do this. We have. You need to do, our value is 7 minus just lower 3, or the result of it, right? I really like a function call. So we'll do this. We started at the ends. Okay, yeah. Then this is 7. Are you less than it? No. So decrease R. Are you 7? Less than it? Yes. So 0. Are you less than? Oh, all the values that are smaller than this. God, okay. Count how many numbers are less than 6. Or actually, I don't even need to do +1. I'll just do it at the. Oh, actually, it might be a math thing. Now, how many numbers are less than this plus 1? Then, and how many numbers are less than this? So by, oh my god, it's like some probability stuff right here. Like there's this like trick for that. Then subtract it, right? This would result. So let's see, how many is this? This is 1, so we have 1. 2, 3. Wait. This is 1. The 0.5 is 5, so that counts. So it's gonna be 0, 1, 2, 3, 4, 4. So 4. So actually 4. We get, I think, 4 numbers. 3 numbers, 2 numbers. So 4 plus 3, 7, 9, 10. How did this count? 10. Yeah, 10. So we get 10 minus smaller than the upper bound. So it's the one that counts will be this one. This would be 1. So 10 minus. I guess this is not supposed to be. I think it's supposed to be. Wait, hold on. This counts. Wait, what do I store? Oh, increase L. I missed it wrong. If it's valid, then we have to increase L. Okay, so let's go back to here. So we go here. So this is not valid, so just decrease it. This is valid, so 0 plus 5, valid. So that's, I think it's It was actually would be freaking more. 0 plus 5 is 5. That's in the range. It's less than it, so we're good. This is 0, 1, 2, 3, 4. So we add 4. Then we do 0 plus 4 is 4. And we have to increase L actually. Increase L, so we do this. This is 1, 2, 3, 4. 4 minus 1 is 3, so 7 here. This is valid, so since it's 6. And this won't be valid, this won't be valid, so this is 7. Actually, this will, oh my god. Valid. Wait, this is valid, and this is 1, 2, 3, 4 minus 1 is 3. Increase this. 4 plus 3, 7. Then we do, that's not gonna work. Push this down. This will work. No, this won't work either. 8. We're at 7. And then how many values for less than 3? Well, none of these work. None of this works. This works. This works. So it would be 7 minus 1. What am I missing here? Should have been 7 minus 1. Oh, we don't check the... I feel like should have been... I think I should have counted one more. 0, 1, 2, 3, 4. 0, 1, 4 minus 0. What else should we have counted? 1 and 5. So 1, 3. Yeah, and then here. Nope. Yeah. We don't have a... That's 8. Anything less than 7. Wait. This just counts. That's 6. Count and we have to move L up. And then 4 plus 5 is 9. Bring this down. 4 plus 4 is 8, so we bring this down so it doesn't stop. So it's 7. 7 minus 1, so and the answer is, oh, 6. Yeah, 7 minus 1, 6. Okay, it works, actually. I think I get the thing. So let's make a helper. Helper takes n value. What we gotta do, this is this. Actually, it's gonna be this. Nums dot sort. Turn helper. Nums and upper plus 1 helper nums upper minus or is lower. It hasn't been implemented, is that why? Let's do L equals R equals length of nums like n. While L if nums l plus nums r value, then what's like n, then I think that's good, right? So we want to res that, and more like the because there's all the values in between it essentially are good, right? So we want to do r minus l, not just that pair. Pairs in between it are valid. So, and then l plus else, just move r, and that should work. Anyways, this works. Thanks for watching. I'll see you for tomorrow's video. Yeah, kind of a mid attempt, but it's okay. Get better. Oh, got a time limit exceed. Oh no. Anyways, thanks for watching. I'll see you for tomorrow's. Peace.